Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to discuss about a very important concept related to consumer offset commit, and that is out of order commit in Kafka. So what is that? Let us try to understand with a very simple scenario. So suppose here we are having our Kafka cluster, okay. So here I can write Kafka cluster, and here this is basically our cluster logo. And suppose here we are having a Kafka topic, and in this topic we are having messages 1, 2, 3, 4, 5, 6, 7, 8 and so on. Okay, let me just make it separated with box. Okay, right. And here also the messages are keep on going. I have not written. It is a continuous flow, as you can easily understand. Now here suppose we are having a consumer. That consumer may be a part of consumer group, and this is our Kafka topic, and the consumer has basically connected with this topic and continuously polling for the messages. Okay, so here first what our Kafka broker will do based on the poll request. First, suppose for example it sent the message 1. Okay, so consumer got the message 1. Then broker has sent the message 2, consumer has received the message 2. Broker has sent the message 3, consumer has received the message 3. Broker has sent the message 4, the consumer has received the message 4. Like that, continuously it is getting messages. Okay. Now, consumer is processing that and sending the acknowledgement by committing the offset in __consumer _offset topic, right? Now suppose consider a scenario that broker already sent the messages 1, 2, 3, 4, but the consumer only sent offset commit for this message 4. Okay, for 1, 2, 3, for this set of messages, the consumer has sent no commit to Kafka cluster. Okay, and after committing the offset for the message 4, suppose the consumer went down due to some reason. So what is the current scenario? Broker has sent 1, 2, 3, 4, these 4 messages. Out of that, for 1, 2, 3, these 3 messages, broker has received no acknowledgement or offset commit from consumer. But for message 4, the consumer has sent the offset commit, and in __consumer _offset topic, for this particular message 4, the offset is committed. Now the question comes, when the consumer will spin up again, then what set of messages broker will send to the consumer? Will it send 1, 2, 3, 5, 6 and so on? That is because initially it has not received the acknowledgement for 1, 2, 3, these 3 messages. Will it send again? Or broker will start sending the messages 5, 6, 7 and so on. That is basically the second option is saying whether the broker will start sending only those messages which are coming after the latest offset commit. Whether this second option will be followed or whether the first option will be followed, where broker will basically send all the previous messages for which it has not received any acknowledgement and all the next messages also after the latest commit. Which option is correct? That is what we have to understand. Okay. So pause the video and try to think about the answer. Here I am explaining, and I will prove the answer with the real-time experiment using Python code also. So just before going ahead with the answer, just have a try. Okay. So the correct answer is this one. That is, broker will not check that for individual messages it has received the acknowledgement or offset commit or not. That is, for 1, 2, 3, this set of messages it has not received the acknowledgement, so it does not mean it will send again. What it will do, it will just check in consumer offset in this particular topic for this particular consumer. What is the latest committed offset? It will get that, okay, latest committed offset is still message 4. Okay. So it will send all the messages after this particular message 4, that is 5, 6, 7, 8, so on. That is the second option is the correct one. So in simple words, you can remember like this way, that consumer offset, whatever it is committing, it is acting like a bookmark. After this bookmark, whatever messages are there, that only it will be sending. Previous to that bookmark, whatever messages are there, broker will by default understand that all the messages are successfully processed and consumed by the consumer. If they are failed, then also the broker will not resend, because the latest committed offset till message 4. I hope you got the idea clearly. That is basically called as out of order commit. Okay. It is having its certain advantage and disadvantage both. Why it is called out of order commit, I hope you can easily understand. Ideally, what should happen that first in the consumer offset, we should be receiving the acknowledgement for message 1, then acknowledgement for message 2, then acknowledgement for message 3, and then 4 and so on. But here directly we are getting the commit for message 4, not for earlier. So that's why it is called out of order commit. Now, what is the disadvantage which we might encounter in certain situations? Like for example, if you think like this way, suppose your consumer is consuming the messages consumed 1, consumed 2, consumed 3 and consumed 4, and then parallelly in the backend using multiprocessing it is processing that, and suppose 1, 2, 3, those 3 messages when it is processing it failed, but that processor which is processing the message 4, that has not failed. So what will happen? The consumer will commit this particular message 4 processing in the consumer offset, and although the 1, 2, 3 these messages processing failed, but the broker will not send it again. That way, this set of messages 1, 2, 3, this set of messages might be missed. That is one of the issue what we might face in case of out of order commit, right? But suppose you are not having that kind of situation. Suppose you are processing the messages using only one thread or something like that. Then this out of commit may result into some advantages as well. And what is the advantage? The advantage is that committing on every message individually would produce a lot of overhead in practical situation. Okay. That is, as soon as consumer received the message 1, after processing it is committing. Then it is going to message 2, after processing it is committing. Like that, if the consumer is committing individual messages one by one, then it produces lot of overhead, because that committing offset is a complex operation overall. So what the consumer can do as a efficient process, it can basically take a batch of messages, maybe 1, 2, 3, 4, like that. Certain batch of messages it can consume together and then process all of them, and then finally it can commit only the last message offset for that batch. That way the whole batch commit will be done and the broker will not send those batch again. So this is another advantage, that instead of committing offsets for individual messages, we can consume a batch of message and then only commit the last offset for that batch. This is one advantage of this out of order commit. So I hope you understood the out of order commit concept. Now let's try to implement the same situation in Python. That is what we will do. First, we will basically disable auto commit, and that way only manual commit will be available. So consumer need to commit the messages, and then what we will do, 1, 2, 3, 4 like that messages will be sending. For 1, 2, 3, we will not commit anything, and then for message 4, after its processing, we will commit that particular offset, and then we will stop the consumer, and then we will again resume the consumer, and then we will see that whether the broker is returning 1, 2, 3 and then 5, 7 so on, or it is only sending 5, 6, 7 so on as per our theory, right? So let's check that with Python now. So I will switch to my notepad. So here what I will do, I will start my zookeeper first in the terminal, and then here I will start my Kafka broker. And then here I will create a topic for this experiment first. Okay. So here zookeeper is running, broker failed. Let me just try to run it again. So it is failing. Why it is so? 2.123 Kafka. So here our broker started, right? And then here I will create the topic. So here topic got created. So first we will see a simple experiment where individual messages whenever we will be getting, that we will be committing, and then we will observe the __ consumer _ offset topic, that what it is happening there. Okay. So here we are having a simple producer. We are having our custom partitioner. where we have written a very simple logic, that is the key part we will be dividing by total number of partition, and based on remainder we will move the particular data point to that respective partition, as simple as that. And then here we have given the same topic name, and here we are sending some messages with 10-second interval. And here we are having our simple consumer code, which I already discussed multiple times in my previous video. Each time whenever we are consuming the messages, we are committing that in the consumer offset topic after processing, and we are printing that messages also. Okay, so here what I will do, I will start my consumer first, and to check what is happening in the consumer offset topic, you can execute this particular code, that is console-consumer.bat file. We can start with the server URL. The topic name you have to mention __consumer_offset topic only. To read the messages from this particular system topic, what we need to do, we need to mention this formatter, and we want to read from beginning. Okay, so I will start this in command prompt. So here it started. As of now it is empty, which is obvious because here consumer has not committed anything. Now here what I will do, I will start our producer code. So see, it published message 0, and in the consumer offset system topic, here you see that message 0 offset it has committed. If you see this one is basically our consumer group name. If you observe in our consumer code, the same group name we have given. Okay, so for this particular consumer group, this is basically our topic name, and this is the partition. So for this particular topic, only one partition is there, so it is showing only 0, and then it has committed offset 0, so that means it will start consuming from offset 1. Then it has committed offset 2, that means it will start consuming from offset 2, like that, and see offset 3, 4, 5, like that. As the messages are keep on coming, here in the consumer offset topic, it has committed the offset also. Offset 5, this is basically indicating it will start consuming from offset 5 next time. Now it is offset 6, that means it will start consuming from offset 6 next time, like that. Okay, that is, here we are committing current offset plus 1, that is from which offset next time it will consume, that we are writing in the __consumer_offset topic. So like that it is happening. So as of now what we are doing, after individual message consumption, we are committing the offset. That is the normal default behavior what we generally observe. Now what I will do, for simplicity purpose, I will just make this cluster clean by stopping the server and zookeeper. Okay, and here I will go, I will delete the zookeeper logs whatever they are, and I will delete the server logs also, and this also I will be terminating, or maybe I can close this window itself. So here now we will start a fresh Kafka cluster, and we will do that experiment what I discussed in PowerPoint. That is, this time if the message value is 4, then only we will commit. Okay, and after committing that particular message 4, we will exit the Python code, or the consumer will stop. Okay, and then again we will start the consumer, and then we will observe whether it is starting consumption of messages from 1 to 3 and then 5, 7 so on, or only it is consuming the messages like 5, 7 so on, that is after the latest commit. Okay, so you will observe that. So here what I will do, I will start the Kafka zookeeper first, and then here I will start the server, and then here I will create another topic this time, and the topic name is sensor data consumer. So that topic I have created. This particular consumer is consuming from sensor data consumer only. In the producer I will make sure I have given the same topic name, and I have saved this. Now observe this particular experiment very carefully. I will start running my consumer. As of now it will be displaying nothing, because in this particular topic no message is published. Parallelly I will open my consumer group. So here you can see that the consumer group started. It will print nothing because as of now no message consumption started. Now here I will start running the main code. Okay, so first message is it has published. If you see the consumer, it has consumed. Okay, but because we have written the code such that only for the message 4 it will be committing the offset, so in the consumer offset nothing is coming. Now the producer has published the message 1. In the consumer you can see message 1 came, but in this particular consumer offset topic nothing is there. Now the consumer has consumed message 2 because the producer has produced message 2. Okay, and then the consumer will produce message 3. Okay, it has produced. Till now nothing is there. Now the producer will produce message 4 and consumer will consume that, commit the offset, and then and there it will exit the code. See here, it has consumed the message 4, and when it has consumed the message 4, you can see that it made a commit. What it has committed, that this is the group ID, this is the topic name, this is the partition, only one partition is there, so partition 0 is fine, and offset 5. That means next time when the consumer is pinning up for this particular partition, it will start consuming from offset 5. And the broker will understand for this particular partition, all the messages coming before offset 5, all are processed successfully. Although for message 1, 2, 3, it has not got any commit, but it will act this offset 5 as bookmark, and it will understand, okay, before offset 5, whatever messages are there, all are processed. It will not at all bother that whether 1, 2, 3 messages are successfully processed or not. Okay. Now see the producer. Here it is continuously producing 5, 6, 7, 8, 9 and so on. All I will do, I will start the consumer and observe from where it has started. It has started from the message 5. Okay. That is 1, 2, 3, for which the consumer has not sent any acknowledgement or offset commit to the consumer offset topic, but still it has not resending those messages because the offset 5 is acting like a bookmark. Before that, whatever is there, those are already processed. The broker will understand that. So I hope you understood in this particular context, if the sequence of messages are there, and for the message 4, if in the consumer offset we are committing, then the broker will not at all bother within that particular partition, whatever earlier messages are there, whether they are processed successfully or not. Okay. So this way, we can use this particular out of order commit in our advantage, that we know committing offset for every message is a overhead. So we can consume a batch of message after successfully processing that batch. Only for the last message for that batch, we can commit the offset. That way, within that particular partition, whatever earlier messages are there, the broker will understand all are processed successfully. So this is one of the tricky concepts which I thought to discuss, which might help you in twisting your consumer code or have some more better idea on how consumer works. All the codes I'll be providing in the description box or in the comment section. Just try to play with it, have some more better feeling out of it, right? This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.